So I'm here to derive the energy net dipole formula. First, we start out with a point charge, an electric field, and we have a dipole, negative and positive. This is my radius positive, radius negative. This right here is the energy field that is produced from the positive charge. This one is from the negative charge on this area, this spot right here. And this is our what the energy field is all together, where it is, in what direction. And I'm going to prove that. Now we start out with the vector r plus the radius, and the final minus initial, and your final would be, since you have nothing in the x or z direction, it's 0, and your y up. So your y, and that's the same for your r negative. And then your initial from the plus side is half of s, because it's on the right side, so it's positive, and you're not up on the y or the z, so that's how you get that. And on the negative side, since it's on the negative, think of this as an x and y axis, it's on the negative x, so it's negative s over 2, no y, no z, so zeros. And you get, for your r plus, s over 2, negative s over 2, y 0, and your r negative would be s over 2, y 0. Your magnitude of r plus and r minus would equal the same thing, because negative s over 2 squared is the same as saying s over 2, because a negative times a negative is a positive, so that's why those magnitudes are the same. Now for r hat plus, you would put the vector r plus over the magnitude of r plus, and you would get this. You do the same for r hat negative. You would do the vector negative over the magnitude of the negative vector. And now we have an energy field from our equation. Our first equation, E equals 1 over 4 pi epsilon naught over Q times Q over R squared times R hat. So right here you would put 1 over 4 pi epsilon naught. You have your charge, which is positive, so it's positive Q, over your R. This is the magnitude of R, positive, times your R hat. And the same with the negative, 1 over 4 pi epsilon naught over negative, since it's a negative charge, negative Q, over s over 2 squared, because this is the magnitude of R negative, vector of R negative, and is your R hat. And so you add them together to get your sum. And when doing so, since you have common denominators, you have 1 over 4 pi epsilon naught times 1 over s divided by 2 squared plus y squared. It's 3 over 2, because when you times these two together, you would get 3 over 2. And so you keep the denominator the same. And on the top, you would add the top. So you would have, for your r plus, you would have negative q s over 2, comma, and this is your y vector, and it's positive q y, and vector plus negative q s over 2, comma, negative qy. So after you add these together, you'll see that you'll get a negative 2 qs over 2, and your 2's cancel, so you'll have a negative q times s, and your qy minus your qi will equal 0. So you take the magnitude of your final, or your lump sum of your electric field you'll get of the dipole. Magnitude would be 1 over 4 pi epsilon naught times your charge q over s, because the magnitude changes that to a positive, over s over 2 plus r squared. We put r here because it's just easier. It's just the radius from the origin of the dipole, and 3 over 2. Thank you.